Hello friends, we are solving this problem 2294 partition array such that maximum difference is k. So we are given an integer array nums and an integer k. So you may partition nums into one or more subsequences such that each element in nums appears in exactly one of the sequence. So every element can appear only one of the subsequence. So we have to return the minimum number of subsequences needed such that the difference between the maximum and minimum values in each subsequence is at most k. So we can understand it like this. So for example, this is our nums and this is our k is given 2. Now we have to find how many subsequences are there, which if we take any of two elements, the difference should not go more than 2. Okay, it should be up to 2. So k is the value here. So we can understand here. So you guys can observe here that if we look for this subsequence 3, 1 and 2, right? So in this case what is happening, this is one subsequence. So 3 minus 1, it is going only up to 2. 3 minus 2, that is also 1. 1 minus 2 is 1. So we can say that 3, 1, 2 could be one of the subsequence. Okay, 3, 1, 2 is the one of the subsequence. Can we bring this? If we take 6 also, 3 and 6, so difference is 3. So we cannot take this in this subsequence, right? So only this would be the one subsequence which is a legit subsequence. How about the other one? So what if I took another subsequence? This is 6, right? 6 minus 1, we cannot take this guy. 6 minus 2 is also 4. 6 minus 1, 5, which is greater than k. So what if we take 6 minus 5? What it is? It is basically 1 only. So this also becomes a legit or subsequence. So 6 and 5. This also could be the one of the subsequence. Now you can see that all the elements has appeared only once in a subsequence. You can say 3, 1, 2 together, 6 and 5 in a different subsequence. So in this case, our answer, how many subsequence we have found? We have found 2. So our answer should be 2 here. Okay. So similarly, we have to solve this problem, that how many such subsequences are possible out of this nums and for the given k. This is what we have to do. Now you guys would be observing one thing, that I have randomly picked these numbers, right? Because as a human, I am just picking by observing it. 3, I picked 3 and 1 and 2, right? But that's how computer would pick. That is the thing. So if we know that we have to find how many subsequences are there, right? 3, 1, 2. I know that in subsequences we cannot change the order of their appearance, but still in this question we are only supposed to find how many are there. Okay, so there is no harm that if I write a subsequence like this as well, 1, 2, 3. Okay, similarly 5 and 6, because anyway we are finding the number of the subsequences, we are not printing the subsequence itself, right? So this gives us one intuition here, that we can, if we sort this array, our work would be simple. Okay, because anyway we want to print the number of subsequences, not the subsequence itself. That is why sorting would make a help to us. So how it would help is, like, let's say if I am sorting this array, it would be looks like 1, 2, 3, 5, 6, right? 1, 2, 3, and this would be our 5 and 6. So now it is easily, we can start from this very first element, right? Let's say we are starting from here. So this would be, let's say we are calling it min, because any bin sorted array for any subsequence, the first guy would be the minimum always. So now we are traversing from here. So let's say after setting this guy as min, if we are starting from here, we will check that what is the difference between 2 and min. It is 1 only. So 2 minus min is 1. So that means this is a legit one, because k is 2 in our case. So this is a legit one, so we can add this guy also. Now answer, we can start answer is equal to 0, 1 initially, because anyway first element we have picked, right? So now we are coming to here at 3. We will check that what is the 3 minus min. So 3 minus min is also equal to 2, which is not going more than k. So 3 is also included. So answer we are not increasing so far. Okay, now finally what will happen after we are going 1, 2, 3? Okay, So when we are coming to this guy 5, so what is the value? 5 minus 1. So 5 minus 1 is actually 4, which is violating our rule because this is greater than k. So this is greater than k, then what will happen? We will increase the answer by 1. So our answer would now become 2 and our new min would become this guy, the one who first time violated our rule. So we would pick this guy here and then we are starting from here. So now again we will check that, hey, what is the difference between 6 and current min? So current min is 5. So 6 minus 5, this is 1 only. So this is also legit. Okay. So that is also a legit value. So finally we have answer equal to 2. So whenever a change is happening, whenever a violation happening, at that time we are increasing. So this utility would be help us to solve this problem. But the thing is, here I have written in the title also that it is a linear solution. But where is the linear? Sorting text or n log n, right? So here, because the maximum value in the question for any number is given up to 10 to the power 5, which is not very huge value. That means here, instead of going to a normal sorting, we can use counting sort. Okay, so counting sort, I have given the description, in the description box I have given the link, but let's solve it by counting sort. So in the counting sort, you guys know that we use a frequency array. Okay, in the frequency array we keep on the frequency of all the occurrence of the elements. Okay, and based upon that, whoever has the frequency greater than 1, that means this is appeared in the array. So based upon that, we would interpret the same way. So let's say if I create a frequency formula, a frequency array. Okay, so this frequency array of what would be the size of it? Size of it would be whatever is the maximum value in this array. So 6 is the maximum, so maximum plus 1. So we will create an array of size 7. Okay, so we'll create an array of size 7 and then we would be try to fill it. Okay, so it would be 0 1 2 3 4 5 6. Okay, 4 5 and up to 6. So why I did plus 1? Because we want to start from 0, so that max plus 1, so all the values would be covered. So let's start from here. So this is 3. So we will add 3, we will increase the count by 1, because initially you can consider all of them are 0. Now we are 6. This 6 came first time, so we will make count equal to 1. At 1 it came first time, so here also count would become 1. Let's say there are one more, so at 2 also it came one time. Similarly 5 came one time, but 4 didn't came at all, so it is still 0. So by default you can consider it as 0. So 0 didn't appear, 4 didn't appear, all other guys appeared. So whoever has the frequency greater than 0, that means they are appeared. Now you can observe one thing here in the counting sort concept. In this way, when we are going from left to right, this is the sorted, these index are sorted, but out of these sorted, if we pick only those guys whose frequency is greater than 1, that means that is the true values which are existing in this array. So what it would be looks like, if we go here 0 didn't come at all, so we will not pick it. But see here, 1 came once time, so greater than 0, so we will pick 1 here. Similarly 2 came greater than 0, so 2 also would be picked. 3 index came once, so 3 also would be picked. 4 index didn't occurred at all, so 4 is not available. 5 appeared, so 5 would be picked. 6 also appeared, so 6 also would be picked. Now you can observe this is sorted in O of n, right? This is sorted in O of n. Now similar concept can be applied here. Okay, so in this frequency itself we can apply. We need not to write the finely sorted one. With this frequency array itself, we can interpret greedily to our solution with the same thing what we did. So how do we do that? Let me show you in my code. So see here. Yeah, so see here what I am doing here. This is my max variable which I want to find it from here. So see here, first of all I am getting what is the maximum value in this array. Okay, just like in this case it was 6, right? So we have to find that maximum value. So I found maximum value, then I'm creating a frequency array with max plus 1, so that we will cover the 0 index as well. Now what I'm doing here, I'm using a for loop. Okay, for the nums, for every x I'm increasing the frequency. Okay, because that means they appeared. Okay, now after doing this, our frequency would be look like this. We got a frequency array like this. Okay, so now what will happen next is we have started answer equal to 0. Now you would have observed I have also created one min variable with minus 1 lakh 1, right? Why I am taking this? Because we want a minimum value anyway. So out of that range I have taken this value. Okay, I could have choose integer dot min value also, but I have given the range, so I have chosen this. Now what I am doing is, after getting populated with the frequency, I am coming to this for loop. So I am starting I equal to 0 to I less than or equal to max, because we choose max plus 1 as the size of frequency array. Now see here, if frequency I means of any index, if frequency I is greater than 0, that means it was appeared, and because we are going from left to right, it is considered as a sorted one, because we are starting from 0 1 2 3 like that. So we are starting from frequency I equal to greater than 0, so that means it is appeared in this array. And if we take the difference I minus min, if I minus min is greater than k, at that time this would be a changing point, like in our case when 5 appeared, at that time 5 minus 1 was become 4, so it was violating the rules, right? So same way we are checking this condition. So in that case what we are doing, we are making a new min. Okay, new min would be we are starting with the I, and answer we are increasing by 1. Okay, so same way we will be doing it, and we are returning answer. So in this way what we are doing is, we are able to solve this problem in linear time complexity. But considering the fact that the min is not, the maximum value is not very huge here. If it was very huge, then there was no point of using this counting sort. But remember, whenever we are doing any sorting problem, and if the maximum value is not very huge, in that case we can go for the this counting sort concept. So let me execute this code, which I have already executed, but for the sake of video I am doing it again, and let me try to submit it. So yeah, I am submitting it, and let's see. Yeah, so it is 99.29% faster. So thank you for watching this video, and if you guys have any concern, please make a comment over there.